see the twin on the left is far younger, or is looking far younger than her twin on the right. Would you agree? And I can put the gene maps and put it on top of them, and I can see, well, you can explain it through differences in gene expression. So we're not talking about gene mutation here, because remember, these are identical twins. We are only talking about that those genes are expressed differently in a twin versus her identical partner. And that is a key insight why we think with the ageLOC approach, we can find these age-related genes and we can put them or classify them into youth gene clusters. And how do we do that? We have the methodology to do it now because of this biochip. It's called a gene chip. And you can put, as I show you, a magnified picture from this particular chip technology. You can look at all 25,000 genes. I've mentioned to you, if you leave it at that, there's no way that you can find these age-related genes. What we have done with our collaborators and with our insight that we have gleaned over the last 25 years of innovation in product development, we're now able to find these age-related clusters. And we call them a youth gene cluster. And if we expand the cluster out, you can see on the right, all the way to the right, that you have several bands in the youth gene cluster. In this example, the YGC as an acronym shows you that in this particular cluster, you have more than 60 genes that you're looking at. But more importantly, the color is significant, or the color of the gene, because it tells me what level of activity that gene is functioning at. A yellow tells me, it's working pretty good. A blue shows me it's not working very well, or at least the expression of that gene is downregulated. We call it in science. So, what we're talking about here is balance, guys. We're not talking about a single gene. There is a company out there claiming that if you regulate this gene, that's all you need to do to have an anti-aging effect. That's barking up the wrong tree. You're talking about multiple genes. You're talking about certain genes that are related to the acceleration of the aging process. Those genes, you actually need to turn it down. Those genes that are related to preserving your youthfulness, you actually need to get them a little bit more active. That's balance. That is what we call resetting a youth gene cluster. It's not about just one direction. It's about a careful balancing, because the youth gene cluster has both genes that you need to turn down and genes that you need to turn up. That is the key differentiation feature of our ageLOC approach. It's subtle. It's a nuance, but it's a key nuance. It is what defines ageLOC, this resetting of the youth gene cluster. And I'll give you an example of resetting. All those genes on the left, and I just merely call them gene 1, gene 2, okay? They're all the same color. In other words, they're all reacting somewhat in the same degree of activity. When we add our ageLOC ingredients, for example, in our transformation system, on and treat the skin tissue containing these genes, we can reset the pattern of activity. And it shows up as orange ranging all the way to blue. Okay? And I'll tell you a little bit more, and here you can go out and become a real geek. And the gene 1 is a gene responsible for making collagen. And you all know that collagen is one of the major proteins or fibers in your skin that keeps it looking young and firm, right? Everybody knows that. That's why you have collagen injection in Los Angeles area. Okay? So you can actually inject the collagen to firm you up. But instead of doing that, we can actually activate the gene that already exists in the skin to make it, to tell it to make more protein. And in this instance, it's collagen. That gene you need to turn up. Let me look at gene 2. And you notice the color is blue. Blue means you're down-regulating or turning down that gene. And that gene makes an enzyme that destroys collagen. It's called collagenase. That's the other. In the body, you always have proteins. Some proteins are considered as enzymes, and some are considered as structural proteins. So for gene 2, it's a collagenase gene. And that gene, you want to make sure that you keep it quiet. And indeed, with our ageLOC ingredients, we can do that. Perfect illustration of the resetting. Perfect illustration of this balance we're talking about. So if you turn down the collagenase enzyme, so less collagen is being destroyed. So you're preserving that. And if you tickle the collagen gene to make more collagen, so 1 + 1 = 2. Less destruction, more production of the protein. That's how we achieve the clinical benefit. And these huge gene clusters, we have mentioned to you quite a few of them. And we told you that with our transformation system, we can classify or group these genes into 4 huge gene clusters. And each cluster is responsible for a specific benefit to the skin. We have a cluster responsible for skin structure or skin firmness and integrity. We have another cluster responsible for making sure that you don't have too much pigmentation. We have a third cluster that is responsible for making sure that you have a nicely hydrated skin tissue. What does the dermatologist say? Moisturize, moisturize, moisturize. For skin health, what does that do? That is to keep your skin hydrated. We do it at a genetic level. The 4th cluster is responsible for making sure that you have those new cells that come into the skin, that we can also reset those cells back to its youthful state. So we have taken these clusters and we've done a clinical study. And once again, talk is cheap. Everybody talks. I don't want to talk anymore. I just want to show you they've done the clinical study and we have the evidence, the link, the activation, or the balancing of these huge gene clusters to clinical, distinct clinical benefits that you can see. And that's why when Tanya was up here talking to you, you got excited. That's why we have those testimonials, because we can translate those genetic improvements or that genetic balancing to a real benefit on the skin tissue. It's not just science. It is science in action. And the clinical studies, in every attribute that we looked at, we can see a 50% improvement. And Tanya can talk more about this clinical benefit. But it is important for us, or for you to remember, it's great for most health professionals to listen to something about genetic changes, but at the end of the day, the bottom line is, will my patients see some benefits? And I think, based on this kind of clinical studies, we predict that you will see significant improvements. And importantly, it's not, the results are great, appear quite quickly, 8 weeks in 7 days. And importantly, these benefits persist for a long time. It's not just something that comes and it goes away. You've asked for validation. You've asked about our scientists. Well, this is all good. All right, show me that your science has been validated. And it is being validated as we speak. Here's an example. This is one of our scientists, Ramona Gopal. She presented last month all these studies that we've been talking about, these huge gene clusters and so on, in a scientific symposium or scientific